Very good morning, students. Let us start our today's class with a prayer. God grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. Amen. Dear children, let's see the 12th lesson in chemistry, atomic structure. Let's enter into the lesson directly. Every substance in our surrounding is made up of unique elements. There are 118 elements identified worldwide so far. Out of these elements, 92 elements occur in nature and the remaining elements are synthesized in laboratory. Copper, iron, gold, silver are some elements found in the nature. Similarly, elements like plutonium, neptunium are synthesized in the laboratory. Each element is made up of similar minute particles that are called atoms. For example, the element gold is made up of gold atom which determines its character. The word atom is derived from Greek word atomos. Tomos means smallest divisible particle and atomos means smallest indivisible particle because in the earlier stage they thought the atom cannot be divided further. Ancient Greek philosophers like Democritus have spoken about atom. Even in Tamil poet Avvayar has said many things about atom. In Tirukural also, Anuvai Tulai Tel Kadalai Pugatti Kuruga Tarita Kural. That is the a prizing word for Tirukural. Okay, but there is no specific theory or scientific theory to prove that atom is there. But John Dalton did that. So here in this lesson, in the beginning of the lesson, we are going to see few theories about atom. Some atomic theory we are going to see. For that, initially let's see about Dalton atom theory. John Dalton provides a basic theory about the nature of atom. He proposed a model of atom known as Dalton's atomic theory in 1808 based on his experiments. So let's see the postulates of Dalton's atomic theory. First one, all the matters are made up of extremely small particles called atoms. Greek philosophers Democritus used the same name for the smallest indivisible particles. Atoms of the same elements are identical in all aspects. What is the meaning? Size, shape, mass and property. In all the aspects they are identical to each other. Third one, atoms of different elements have different size and masses and possess different properties. Fourth one, atoms can neither be created nor be destroyed. That is, atom is indestructible. Atoms of different elements may combine with each other in a fixed simple ratio to form molecules. An atom is the smallest particle of matter that they take parts in a chemical reaction. So, do you know in do you know section they have given about John Dalton. You'll go through that. What is the advantage of Dalton's atomic theory? Dalton's theory explains most of the properties of gases and liquid. This explains the law of chemical combination and the law of conservation of mass. This theory helps to recognize the molecular differences of elements and compounds. There are some limitations, many limitations in Dalton's atomic theory. What are they? Atom is no longer considered as the smallest indivisible particle because they can be divisible. Atoms of the same elements have different masses. Isotopes are examples because their mass number is different. For isotopes, mass number is different. For hydrogen, H1. 1 is the mass number. Deuterium H2, 2 is the mass number. Deuterium 3 is the mass number. Okay. Atoms of the different elements may have same masses. Example, isobar. You might have seen the examples for isotones, isobars, isotopes. Substances made up of same kind of atoms may have different properties. Example, coal, graphite, diamond. They are all made up of carbon, but their properties are not at all similar. But in his theory, he said the properties will be similar. It is a wrong one. Okay. What are the fundamental particles? In 1878, Sir William Crookes, very important experiment. Okay, while conducting an experiment using a discharge tube, found certain visible rays traveling from two metal electrodes. What are the electrodes? Anode and cathodes are the two metal electrodes. So invisible ray passed through two electrodes. These rays are known as Crookes ray or cathode rays. The discharge tube used in the experiment is now referred as Crookes tube, or more popularly as cathode ray tube, CRT tube, like that we will call. In many higher studies, if you go for physics or chemistry in higher studies, you might have seen this CRT tube. See, cathode ray tube is a long glass tube filled with gas sealed at bottom at both the ends. It consists of two metal plates which act as electrode connected with high voltage. The electrodes which is connected to the negative terminal of the battery is called cathode. The electrode connected to the positive terminal is called as anode. There is a side tube which is connected to a pump. This pump is used to lower the pressure. It is an evacuated pump. It can lower the pressure inside the discharge tube. Okay, electricity when passes through air removes the electrons from the gaseous atom and produces cations. This is called electrical discharge. Discovery of electrons. Let's see the discovery of electron. This you might have learned deeply in your higher studies. A fundamental thing is given in a standard. When a high electric voltage of 10,000 volt or more is applied to the electrode of a discharge tube containing air or any gas at the atmospheric pressure, no electricity flows through the air. However, when the high voltage of 10,000 volt is applied to the electrode of the discharge tube contains air or any gas at the low pressure of about 0.001 millimeter of mercury, a greenish glow is observed on the walls of the discharge tube behind anode. This observation clearly shows some invisible ray coming from the cathode. Hence, these rays are called cathode rays. Later, they were named as electrons. The fact that air is a poor conductor of electricity is a blessing in disguise for us. Yes, really. Imagine what would happen if air had been a good conductor of electricity. All of us would have got electrocuted when a minor spark was produced by an accident. Okay. Properties of cathode rays. Cathode rays travel in straight line from cathode towards anode. Cathode rays are made up of material particles which have mass and kinetic energy. Cathode rays are deflected by both electric and magnetic field. They are a negatively charged particle. The nature of the cathode ray does not depend on the nature of the gas filled inside the tube or the cathode used. So in television tube, cathode rays are deflected by magnetic field. A beam of cathode ray is directed towards a coated screen on the front of the tube, whereby varying the magnetic field generated by the electromagnetic coils, the beam traces a luminescence image. Next, we shall see the discovery of proton. The presence of a positively charged particle in the atom has been preciously predicted by Goldstein based on the concepts that the atom, being electrically neutral in nature, should necessarily possess positively charged particle to balance the negatively charged electron. Goldstein repeated the cathode ray experiment by using a performatable cathode. On applying a high voltage under low pressure, he observed a faint red glow on the wall behind the cathode. Since these rays originated from the anode, they were called anode rays or cathode rays or positive rays. Anode rays were found as a stream of positively charged particle. When invisible radiation fall on material like zinc sulfate, they emit a visible light or glow. These materials are called fluorescent materials. What are the properties of anode? Anode rays travel in straight line. Anode rays are made up of material particles. Anode rays are deflected by electric and magnetic fields. Since they are deflected towards the negatively charged plate, they consist of positively charged particles. The particles of anode rays depend upon the nature of the gas taken inside the discharge tube. The mass of the particle is the same as the atomic mass of the gas taken inside the discharge tube. Let's see the discovery of neutron next, because there are three particles inside the atom: electron, proton and neutron. We have seen about electron and proton. Next we need to see about neutron. At the time of J.J. Thomson, only two fundamental particles, that is proton and electron, were known. In the year 1932, James Chadwick discovered another fundamental property called neutron. But the proper position of these particles in an atom was not clear till Rutherford described the structure of atom. We will study about Rutherford atom model in your higher classes, even in your 9th standard. Properties of neutron. Neutrons carries no charge. It is a neutral particle. It has mass equal to that of proton, that is 1.6 in 10 to the power minus 24 grams or 1.6 in 10 to the power minus 27 kilograms. So in a table they have given you the property of fundamental particles. Next we need to see few atom models. Only one atom model is given to you, J.J. Thomson atom model. Remaining atom models you will be studying in your 9th standard. J.J. Thomson, an English scientist, proposed the famous atom model in the year 1904, just after the discovery of electron. Thomson proposed that the shape of atom resembles a sphere having a radius of the order of 10 to the power minus 10 meter. The positively charged particles are uniformly distributed with the electrons, arranged in such a manner that the atom is electrically neutral. Thomson's atom model was also called as the plum pudding model. You might have seen the pudding cake. Some cashews will be, some nuts will be there, isn't it? Like that, the distribution of positively and negatively charged particle will be there in the atom was proposed by J.J. Thomson. Okay, the embedded electrons resembles the seed of the watermelon, while the watermelon's red mass represents the positive charge distribution. The plum pudding atomic theory assumed that the mass of an atom is uniformly distributed all over the atom, but actual atom model is not like J.J. Thomson atom model. So we will be learning that in your higher studies. What are the limitations of J.J. Thomson's atom model? Thomson's atom model could successfully explain the electrical neutrality of an atom, but it failed to explain few things. What are they? Thomson's model failed to explain how the positively charged sphere is shielded from the negatively charged electron without getting neutralized. This theory explains only about the protons and electrons and failed to explain the presence of neutral particle called neutron. Next we are going to see about valency. What is valency? In order to understand valency of electric elements clearly, we need to learn a little about Rutherford atom model here. According to Rutherford, an atom consists of subatomic particles, namely proton, electron and neutron. Protons and neutrons are found at the center of the atom called nucleus, and electrons are revolved around the nucleus in the circular path called orbit or shell. An atom has a number of orbits or shells. This number of orbits, and each orbit has electron. The electron revolving in the outermost orbit is called valency electron. See in your picture it is shown in blue color. That is the valency electron orbit, valency orbit, and the electrons in those orbits are called valency electrons. Blue color la irukkirathu. The arrangement of electrons in the orbits is known as electronic configuration. Atoms of all the elements will tend to have a stable electronic configuration. That is why we will tend to have either 2 electrons known as duplet or 8 electrons known as octet in their outermost orbit. For example, helium has 2 electrons in the outermost orbit, so it is chemically inert. Similarly, neon is electrically inert because it has 8 electrons in the outermost orbit. What is the meaning? If the electron possesses in the outermost orbit 2 or 8 means it is electrically neutral. It will not react, chemically inert. It will not react to any other substances. It will not make a bond to another molecule or another atom. The valence electron in an atom readily participate in a chemical reaction, and so the chemical property of an element are determined by these electron. When molecules are formed, atoms combine together in a fixed proportion because each atom has different combining capacity. This combining capacity of an atom is called valency. Valency is defined as the number of electrons lost, gained or shared by an atom. Lost, gained or shared by an atom in chemical combination so that it becomes chemically inert. What are the types of valency? As we saw earlier, an atom will either gain or lose electron in order to attain the stable electronic configuration. In order to understand valency in a better way, it can be explained in two ways depending on whether an atom gains or loses electron. Atoms of all metals will have 1 to 3 electrons in their outermost orbit. By losing these electrons, they will have stable electronic configuration. So they lose them to other atoms in a chemical reaction and become positively charged. Such atoms which donate electrons are said to have positive valency. For example, sodium atom, atomic number is 11, has one electron in its outermost orbit, and in order to have stability it loses one electron and becomes positively charged. The sodium has positive valency. All non-metals will have 3 to 7 electrons in the outermost orbit of their atoms. In order to attain stable electronic configuration, they need few electrons. So, they accept these electrons from other atoms in a chemical reaction and become negatively charged. These atoms which accept electrons are said to have negative valency. For example, chlorine, atomic number is 17, has 7 electrons in its outermost orbit. By gaining 1 electron, it attains stable electronic configuration like inert gas electronic configuration. Thus, chlorine has negative valency. Valency with respect to atoms. So, valency of an element is also determined with respect to other atoms. Generally, valency of an atom is determined with respect to the hydrogen, oxygen and chlorine. Valency with respect to hydrogen, chlorine and oxygen has been explained in your book clearly. You might have go through that. Next, we need to see variable valency. Atoms of some elements combine with atoms of other elements and form more than one product. Thus, they are said to have different combining capacity. These atoms have more than one valency. Some cations exhibit more than one valency. For example, copper combined with oxygen and form two products, namely copper oxide and cupric oxide. Copper oxide formula is Cu2O and cupric oxide formula is CuO. So valency of a copper is 1 and in CuO valency is 2. Okay, so this is called as variable valency. Table 12.3 shows you the metals that have the variable valencies. Okay, let's see the types of ions next. Ions are classified into two types. One is cations, another one is anions. If an atom loses one or more electron during a chemical reaction, it will have more number of positive charges on it. These are called cations or positive radicals. Sodium atom loses one electron to attain stability and it becomes cation. Sodium ion is represented as Na+. See, in the first figure they have shown about sodium atom. This sodium atom, blue color, totally 11 electron, innermost 2. In the second orbit 8. 2 plus 8, 10. In the outermost orbit 1. So 10 plus 1, 11. So this is sodium atom. When it going to have chemical combination with another substance, it need to contributes its outermost one electron to the another compound, another substance or element. So it contribute that one electron. So what is the atomic structure of sodium ion? Inner core will be similar, the second core will also be similar. 2 electron, 8 electron, totally 10, but it contribute 1 electron, so positively charged. So Na plus sodium ion is ready. Okay. Similarly, you can explain anion with chlorine atom. Okay. See this anion. If an atom gain one or more electron during a chemical reaction, it will have more number of negative charge on it. These are called anion or negative radicals. Chlorine atom attains stable electronic configuration by gaining an electron. See, the configuration looks similar, but you have to count the number of electrons. for chlorine atom there will be 17 electrons. See the innermost core, two electrons in the innermost orbit. And in the second orbit there will be 8 electrons. 2 plus 8, 10. See the outermost, that blue color, there will be 7 electrons. There will be 7 electrons in the first picture. Okay, so it gain 1 electron from any other substances like sodium. And see the second picture, what is the outermost number of electron? It will be 8. Now the chlorine atom become ion by gaining 1 electron. The chlorine atom become chlorine ion by gaining 1 electron. So this is anion. Okay, so different valent ion. During a chemical reaction, an atom may gain or lose more than 1 electron. An ion or radical is classified as monovalent, divalent, trivalent and tetravalent when the number of charges over it is 1, 2, 3 or 4 respectively. Based on the charge carried by the ion, they will have different valency. So in table 12.4 they have shown valency of some anions. In table 12.5 they have shown valency of some cations. So how much electron they are contributing, that is the thing given here. So chemical formula or molecular formula. How can we attain chemical or molecular formula? They have given you few steps. See the first step. Write down the symbol of element or ion side by side so that the positive radical is on the left and the negative radical is on the right hand side. Okay. Step 2. Write the see the example side by side. Step 1 example, Ca in the left and Cl in the right. Okay. Step 2. Write the valency of the two radicals above, their symbol to the right in the subscription. So write the sign plus and minus in the subscription. See the step 2. How much electron it loses, how much electrons it gains. So 2 electrons calcium and 1 electron it gains, chlorine gains. Okay. Reduce the valency to a simple ratio if needed, otherwise interchange the valency of the element ion. Write these number as subscription. However, 1 appears on the subscription of the symbol is omitted. Okay. Upon step 3, see the step 3 in your example. In step 2, in the superscription, calcium have 2. Okay. But in step 3, in subscription, chlorine has 2. You have to cross the number. You have to cross the number. See this one. This 2 must come here. This 1 must come here. Okay, you have to cross the number. If it is 1 means you need not to show this 1. That's what said here. Next, naming chemical compound. We need to see how we name chemical compound. It is very easy. You may go through and understand it easily. Next, we need to see section 12.8, chemical equation. Chemical equation is a shorthand representation of a chemical reaction with the help of chemical symbol and formulae. For chemical equation has two components, reactant and product. What are reactant? Reactant or the substance that take part in a chemical reaction, and the product or the substance that are formed in a chemical reaction. They have shown the skeleton equation. Step to write the skeleton equation have been shown. Very easy. You go through and find out the steps. And balancing chemical reaction. There are now numerous methods to balance chemical reaction. Many methods. Trial and error method, direct inspection method, fractional method, odd number, even number method. Here we are following some method. It is very easy for you. Just to see the steps and follow the example step by step, and it will be very easy for you. If you couldn't understand, just call me immediately. I'll explain you individually. Next, information conveying by a balanced chemical equation. What are all the information we obtain by a balanced chemical equation? Informations obtained and information that are not obtained given in this section. A balanced chemical equation gives us both qualitative and quantitative information. It gives us qualitative information such as the name, symbol, formulae of the reactant molecules taking part in the reaction and those of the product molecules formed in the reaction. We also can get quantitative information like the number of molecules and atoms of the reactant and the product that are taking part in the reaction. However, a chemical equation does not convey the following: physical state of the reactants and the products. Heat liberates or heat absorbed accompanied by the chemical reaction. Conditions such as temperature, pressure, catalyst, etc., under which the chemical reaction takes place. Concentration of the reactant and product will not be explained. Speed of the reaction also not available. Next, we need to see laws of chemical combination. There are four laws has been given: law of conservation of mass, law of constant proportion, law of multiple proportion, Gay-Lussac's law of gaseous volume. In this lesson, in your 8th standard, you are going to see only two laws. Remaining you will be seeing in your 9th standard. Law of conservation of mass. What is the law of conservation of mass? It is proposed by Lavoisier in 1774. It states that during any chemical change, the total mass of the product is equal to the total mass of the reaction. So, this law of conservation of mass is also known as law of indestructibility of mass. Next, we need to see law of constant proportion. What this law explains? This is proposed by Joseph Proust in 1779. He states that in a pure chemical compound, the elements are always present in definite proportion of mass. This law is also known as law of definite proportions. So up to this, I am going to conclude this lesson. I hope you all understand the lesson. Go through the lesson in a textbook and gain your scientific knowledge. All the best. God bless you. Thank you, girls.